Hello everyone, welcome to today's video. Today we are going to go through the part 2 for algebraic expansion and factorization. If you have not watched the first part to the video, there will be a link given down in the description. So make sure that you watch that video before watching this, because in that video we have covered the basics for expansion and factorization. It's very important for you to understand that before we dive into these special cases. So without any further ado, let's continue. So for algebraic expansion, just a quick refresh. What we have studied in the past video is that, for example, we have the expression x outside, and inside the bracket we have a plus b. So in the classic case of an expansion, what we do is we use something that is known as the butterfly method or the rainbow method, where the number outside is multiplied with the terms inside one by one. In this case, x will be multiplied by a and x will be multiplied by b, which of course we get ax plus bx. Or if you would like it, it can also be written as xa plus xb. I prefer this just because it looks nicer. Ax plus bx. So this is the classic case of an expansion. The same rule applies to this. There is no difference. It's just that there is two terms that you have to multiply by the other two terms. So what we do here is the concept remains the same. So let's take the first term from the first bracket. We have a. So what you have to do is take a, multiply this by c. Don't disturb b first. B, just let it be there, do not disturb it. So we have a times c and then a times d. So you can start writing the answer where you will get a and c. A times c is ac, then plus a times positive d. Make sure you take the positive together. A times d is plus ad. Then once a is done, let's move on to b. So b is the exact same thing. So b times c, and then b times d. So b times c, you will get bc, and b times d, you will get bd. Remember, positive. If it's negative, you have to put negative. Since it is positive, you're going to just keep it as positive. So b times d will get bd. And that's rainbow method using expansion using rainbow method. The concept remains exactly the same for both of the cases, where you take the number, or in this case the term outside the bracket, and then you multiply it one by one with all the terms inside the bracket. In the case that we have 2, do it one by one. That's it. So that's all for expansion. Do not worry if you don't understand the concept right away. If you can't get it, try to rewatch it one more time. But if you still can't get it, no worries. In the next video, there will be a part 3 to this chapter. In that part 3, we will be going through some questions regarding this topic, and also different ways of using this method. So do not worry, just take a look at the video when it drops, and you will be able to understand the mechanics of how this method works. So for expansion, that's all we have for expansion. Now let's move on to factorization. And before we move on to factorization, just one last thing. After you multiply all of this, and then you get this expression, make sure to add them together in case there is a like term. This is very important. When we learn algebra when we learn algebra in Form 1, there's something called as this most simplified version. In that version, it's essential for you to add, subtract, times, or divide anything that has like terms in it. This is to make sure that you do not lose 1 or 2 marks in exams just because you forgot to simplify the term. When you can plus, minus, divide, or times anything that is a like term, make sure you do them promptly so that you do not lose marks. So now we're done with expansion. Expansion is the easy part. Now we're going to take a look at the opposite of expansion, which is factorization. I'm not sure whether you remember or not. Expansion is the process of eliminating the bracket. See, there is bracket, there is no bracket. This is not a bracket, this is just for me, just symbol I used to emphasize it. But expansion is the process of eliminating the bracket, whereas factorization, its counterpart, is where we create the brackets. So for the first one, we have 48xy plus 12y. This is exactly the same concept that I taught you in the previous video, where we find the HCF of the given expression. So, as I said in the last video, make sure you go one by one. First, the numbers. So 48 and 12. So to find the HCF, just use the repeated division method, 48 and 12, which you will get 2, 24, 6. Let's speed up a little. So if we put 6 here, we had 4 and we have 1. And that's it. 4 and 1 are not divisible by a number simultaneously. So let's take this 2 and 6. So we multiply them together and we get the answer 12. So 12 is the HCF for 48 and 12. So we have gotten the first thing, 12. Once the numbers are settled, it's important to take a look at the alphabets. So we have x and y. X only appears in the first term, so we can now take out x as a common factor. After x, we have y. So as you can see, y has appeared in both the terms, and in both terms it appeared once. So with that knowledge, we can divide y from both. So let's add y right here. So 12y. So once we take out 12 and y out of expansion, what we will have inside is 40 divided by 12, which is 4. X. Do not touch x if there is if there's no identical x in the other terms. Just leave x as it is. Plus 12y divided by 12y, automatically we get 1. This one right here. And that's it. That's factorization, the first method. This concept I went in detail in the previous video. So if you want to take a look at it, just take a look at it, no problem. So this is the simple factorization. This is the simplest one and this is the easiest one to understand. So once we have this down, now let's go to the interesting one. Keep this outside of your evaluation for a while, because this will be important afterwards. So here we have m squared plus 4m plus 4. If you notice, this is the first time we are getting more than 2 terms at once in one expression. And the interesting thing is you can't use the first method that we used earlier, because there is no common factor in all of them. So if you take m squared for m and 4, there is no similarities, because you can't take out m because the last term doesn't have m, and you can't take out 4 because the first term doesn't have 4. So here what we have to do is use something that is known as cross method or X method, and there are various names. So I'm going to teach you the manual method of doing it. There's also a way to do it with calculator, but calculators will not be the center of focus during this part of your syllabus. because the syllabus wants you to be able to do this manually because you have to show the working steps in exams. So let me show you. So what happens is you have to have 3 columns. So since this is the first time this is the first time you're ever trying it, let's make it proper. Once you're used to it, you can skip a few steps. So this is the first column. This is the second column. And this is the third column. Alright. I will put this so that you can differentiate the numbers easily. No worries, I'll use different colors so that it's clear. Okay, so we have three boxes. So just for reference, I'll name this as A, B, and C. This will be A, this will be C, and this will be B. Just make sure to invert this position. Okay. So now what happens is, for A, for which we have m squared, give me just a moment, let's put this right over here. Okay. So what you have to do now is take all of the possible terms that when multiplied together will get you m squared. So what you're trying to do is, you're trying to find a combination. You're trying to find different combinations which will result in m squared. So the most obvious one we have is m times m, which will get us m squared. Or there's one more combination, which is negative m times negative m, which will get us m squared. So frankly, this combination, although possible, is rarely asked. And it's wise for us to just neglect this for most cases. But in some very, very rare cases, it is possible to have negative n, negative m. But for this case, let's ignore that. So just take m times m. So m times m is selected. So what we do is we write m and m right over here. So m times m, we get m squared. And then here, 4. So here is C. So what we would like to have is 4. The same concept applies here. We are trying to find all the possible values or possible combinations that will give us 4. So here it's quite simple, where we have 1 times 4, negative 1 times negative 4, 2 times 2, and negative 2 times negative 2. For those who are asking why not 4 times 1, your wish, it's the same thing. There's no difference. 4 times 1 and 1 times 4, and negative 1 times negative 4, and negative 4 times negative 1. We are just changing the order. It does not affect the combination. The combination is still 1 times 4. So we have all 4 of this. For those asking, so how will I know which one to use? Sorry to be the bearer of bad news. You have to try one by one. Yes, there's no other way. You have to try one by one. But after doing it for some time, you will get the feel for it, and you will instinctually know what is the correct answer. So the tip that I can give is that when you're choosing C, make sure to take a look at B. If B is a positive number, in most cases, you will not have any negatives in the combinations of C. This is just a tip. This may not work 100% of the time, but still, it's better than nothing. Which in which case, if the B value is positive, if this is positive, most often than not, the combinations in C will not have a negative number. It will be positive as well. You'll understand why it is in just a moment. So here we have 1 times 4 and 2 times 2. So since we are going to try, let's try 1 times 4. So 1 times 4, we have 1 here and 4 here. Make sure to add the positive signs here as well. So what you have to do now is, this is why you will know why it's called the cross method. You cross this way and you cross this way and you multiply them. So m times 4, positive 4, you get 4m, which you'll write it right about here, 4m. Remember, it's still positive. And then m times 1, which you will get positive m, and I'll write it right over here. Remember to add in the positive sign just to make sure everything's clear. We don't write the 1 because in algebraic expression there is no need to write 1 in front of an unknown. So here, well, we forgot something. So 1 and 4, when multiplied together, will get you 4, positive 4. Okay, so now for column A and C, what we did is we multiplied the numbers together. But for column B, it's quite special. They're going to add them. So what you do here is we take m and 4m and add them together, from which you will get the number 5m, positive 5m. You add them together. All right. So you might wonder, all right, so how do I know whether this is correct or wrong? So here is where you have to compare. Remember this a, from the question we know it's m squared. When we bring it down, it has to be the same, m squared. Then for c, from top we know it's 4, and when we bring it down, it is still 4, so it's correct. So the b must follow the same suit, it's 4m. When you bring it down, it has to be 4m, but it's not, it is 5m. So, which means that this combination, which is 1 times 4, is actually wrong. It's not the correct one. So when you know it's not the correct one, it's quite sad to do, but you have to redo the whole thing, or you can just do it another time. I meant you have done it once, you can do it the second time as well, but using a different combination. So since I'm explaining it to you, I will just use the same column again. So I will erase 4m plus m. And now let's switch it up to 2 times 2. So let me put 2 right about here, plus 2, and once multiplying we get positive 2m and positive 2m right about here, and we add them together, we get positive 4m. So now when we compare, we have 4m in the positive 4m in the question and positive 4m in the answer. So with this, we know that we have the correct terms now. So the answer, you may ask, what is the answer? The answer is right here. Right here. So the answer is m plus 2 times m plus 2. That's it, which will become m plus 2 squared. So now we know why this number is right up here, m plus 2 squared. And this is the cross method explained in detail. So if you don't understand this, try to watch it again, and if you still can't get it, I recommend you to try doing it. Just give it a hands-on experience, so the hands-on experience will help you a lot. Just try to give it a try, or should I say attempt this method using this expression or any other expression. By just doing it once, I'm pretty sure you will start to get the hang of it. But no worries if you can't understand it. In the next video, we will be going through some questions which you can do together to improve your understanding. Moving on, the last special case is where we have four terms. We saw one term, we have seen two terms, three terms. Now it's time to see the four terms. So remember, for the first method, it doesn't matter how many terms there are. All you have to do this particular method is all the terms in the expression must have a common factor. The second method is only used when there are three terms and there are no common factors. And for the third one is when it's used when there are four terms, just four terms, in a special case, just four terms. And these four terms do not have a common factor. So what you do is you break them apart into two pieces of two and two. And you use the first method again, where you take out the common factors of this separately and this separately. So what you do here is you have mr plus nr. So here we're going to factorize the common factor out. As you can see, we have r repeated in both the terms. So we take out r and you will have m plus n inside the bracket. Can you see that? R taken out, we have m plus n inside. The same thing here, we just put the plus sign here, and we'll have mq plus nq. As you can see, q is repeated. We take out q, and you will have m plus n. So here what we have to do is, we take out the term mn, m plus n. This is where this method seems a bit tricky, but no worries, I'll explain it to you. So we have r bracket m plus n and n plus q in bracket m plus n. Since m plus n is repeated in both the terms, we can take out m plus n, and inside we will have r and q remaining. For those who can't understand, no worries, let me explain. So let's assume that m plus n is just one term. For example, x. So when we have rx plus qx. Same thing, x is m plus n is now x. So in this circumstance, what we do is we use the first method where we take out the common factors out of both, correct? The common factor for both of these terms are x. Then we take out x, we have x. Inside we have r plus q. So since x is m plus n, we can just write m plus n outside and r plus q. As you can see, we have done the exact same thing. These two are identical. So we consider m plus n as one singular term and we factorize it out of the equation so that we get m plus n and r plus q. This is the most simplified version for this kind of factorization. This video is just to introduce you to the special cases, and if you can understand them, I would highly recommend you to watch the video one more time. But if you still can't get it, no worries, you just have to understand the gist of it. Detailed explanation and walkthroughs will be given in the next episode. I'm very sorry, pardon me. Not next episode, in the next part of the video, which is the final part, where we will go through a few questions and also working methods to solve it. And there will be a few tips here and there which I will give in order to make this chapter much more manageable. So not to worry, everything is fine. So that brings us to the conclusion of the video. We have three methods and fourth method including expansion. So that's the end of the video, and I will meet you in the next one with the examples and working steps. Thank you for watching, and see you in the next one.